In the last video, we had discussed about the last four identities of this chapter, identities number 5, 6, 7, and 8. And we did some example problems and also some exercise problems related to identity number 5, okay, which is a trinomial with a degree of 2. And we saw examples of how to expand an expression of this form using this identity, and also we saw some example of using this identity to factorize the algebraic expression. So when we are given an expression which has a form of the right hand side of this identity, we saw how to factorize that and get it in the form of the left hand side. Okay, so we saw how to expand this expression and also how to use this identity for factorizing the algebraic expression as well. Now in today's video, in this particular video, we are going to focus on the next two identities, which is identity number 6 and 7, and we will see how we can use these identities for expanding an expression of this form and also for factorizing, and we will also see how we can use these identities for evaluating certain calculations. Okay, so let's start with our first example, which is from the exercise 2.4, question number 6. So we have this particular expression which we have to expand using our identity for x plus y the whole cube. So clearly this is of the form x plus y the whole cube. In place of x we have in the identity, in the place of x we have 3 by 2x, and in the place of y we have 1. So x plus y the whole cube, we have 3 by 2x plus 1 the whole cube, and this is our identity expression for the right hand side. So we just have to substitute for the given values of x and y, and we will be able to expand this particular expression. So corresponding to x we have 3 by 2x, and in place of y we have 1. So we can write our expression 3 by 2x plus 1 the whole cube as we will substitute this in the right hand side of the identity, so which is x cubed plus y cubed plus 3xy into x plus y. So in place of x we have 3 by 2x, and in place of y we have 1. So we just have to substitute that. So in place of x on the right hand side we have 3 by 2x, so that's 3 by 2x cubed, plus in place of y we have 1, so it will be 1 cube, plus 3 times xy, so 3 times x is 3 by 2x, and in place of y we have 1 into x plus y. X plus y is, so in place of x we have 3 by 2x plus y is 1. So we just need to simplify this and we will have our final expansion of this particular expression. So 3 by 2 into x, that is 3x by 2, will give us 3 3s are 9, 9 3s are 27. So that will be 27x cube divided by cube of 2 is 2 into 2 4, 4 into 2 8. So it is 27 by 8 x cube, or 27 x cube by 8, plus 1 cube will remain 1. And then the next term we have 3 into 3 by 2. So 3 into 3 is 9. 9 by 2x into 1. So that will be plus 9 by 2x into 1 is 9 by 2x. And we have in the bracket 3 by 2x plus 1. So we'll keep it as it is, 3 by 2x plus 1. Now we can open up that bracket. So we'll have it as 27 by 8x cube plus 1 plus, when we multiply this term with the first term inside the bracket, so we have 9 by 2 into 3 by 2. So 9 into 3 is 27, and 2 into 2 is 4, and x into x is x squared. So we'll have it as 9 3s are 27 divided by 2 into 2 is 4, and x into x is x squared, plus anything multiplied with 1 is itself, so it's 9 by 2 times x. So we have just opened up this bracket, and now we have our expression, as 27 by 8 x cubed plus 1 plus 27 by 4 x squared plus 9 over 2 times x. And as a final step, we can just rearrange the terms in descending order of the power of the variable. So the variable is x, and we have the power of 3, power 2, power 1, and power 0, right? So we can just rearrange these terms, although not necessary. And just for completeness, we will rearrange these terms in descending order of the powers. So it is 27 by 8 x cubed plus 27 by 4 x squared plus 9 by 2 x plus the constant term, which is 1. Okay, so we will just rearrange those terms so that we have it in a systematic way where we have decreasing powers of x. So x power 3, x power 2, x power 1, and the constant term corresponds to x power 0. So that is the expansion for this expression, and we have used this particular identity, which is identity number 6, okay, x plus y the whole cube, okay, and we have obtained the final expression for this expansion. Let's continue with another exercise problem. This is x minus 2 by 3y the whole cube. So again, this is taking the form of identity number 7, which is x minus y the whole cube. Previously we saw x plus y the whole cube. What we did in the last example is having the identity for x plus y the whole cube. Now we are doing an example for x minus y the whole cube. So now in place of x we have x, so x remains as x in the expression. So in place of x we have the same x, but in place of y we have 2 by 3y. Okay, so y is 2 by 3y, and we have the identity for in the form of x minus y the whole cube, and the right hand side is x cubed minus y cubed minus 3xy into x minus y. So we just need to substitute and simplify. So it's x minus 2 by 3y the whole cube. So on the right hand side we have x cubed. So in place of x we have x, so it will be x cubed as it is, minus y cubed. So in place of y we have 2 by 3y, so it will be 2 by 3y the whole cube minus 3 times xy. 3 times x is x, and y is 2 by 3y, because in place of y we have 2 by 3y into, okay, this whole thing is multiplying x minus y, so x remains x minus y is 2 by 3 times y. Okay, so we will now expand this and get our final answer. So that will be x cubed minus 2 by 3y the whole cube. So 2 cube is 8, and 9, the 3 cube is 27, so 3 into 3 into 3 is 27, and y power 3 is y power 3. Okay, so 8 by 27 y cube, and then the next term we have 3 into x into 2 by 3y. So clearly we can cancel out the 3 there, so let me do that. So this 3 cancels out with this 3 because they are multiplying there. So we will have 2 x into 2y, that with a minus in front here, so it is minus 2xy. So it's minus 2 times xy, and in the bracket we have x minus 2 by 3 times y. So now we can open up that bracket, and we will see we will get x cubed minus 8 by 27 y cubed minus 2x squared y. So basically we have multiplied this term with the first term inside the bracket, so it's minus 2x into x is x squared times y, and then we multiply this term with the second term inside the bracket, so minus into minus will become plus. Then we have 2 into 2 is 4 divided by 3, x, and then y into y is y squared. Okay, so now we have our expansion in this form. There's no way of further simplification of this, so we can leave it at this. So the final answer is x cubed minus 8 by 27 y cubed minus 2x squared y plus 4 by 3 xy squared. Okay, so there is no further simplification possible here, so we can leave it at this, and that is our final expansion for this particular expression over here. Okay, let us now see how we can use these algebraic identities with the degree of 3 to perform some calculations or evaluations of numbers. Okay, so we'll use some problems from the exercise set from exercise 2.4. So we have to evaluate 99 power 3, 99 cube. We can write 99 cube as 100 minus 1. So 100 minus 1 is 99 cube. So now this is of the form x minus y the whole cube, and we know x minus y the whole cube is equal to x cube minus y cube minus 3xy into x minus y. So this is our identity, which we have already seen. So x minus y the whole cube is x cube minus y cube minus 3xy into x minus y. So the only thing now is that in place of x we have 100, and in place of y we have 1. So x equals 100 and y equals 1. So we just need to substitute in the right hand side of the identity, and we will be able to evaluate. So 99 cube is 100 minus 1 the whole cube. So we'll just substitute in place of x and y on the right hand side. So we will get 100 cube minus y is 1 cube minus 3 into x is 100 into y is 1 into x is 100 minus y. Okay, so now we will have it as 100 cube is 1 followed by 6 zeros. So 1, 2, 3, 4, 5, 6 minus 1 minus 3 into 100 is 300. So it's minus 300 into 100 minus 1. So let's open up the bracket. So we'll get, so that's 10 lakh. So 1, 2, 3, 4, 5, 6. So 6 zeros. Minus 1 minus 300 into 100. So that will be minus 300 into 100. So that's 4 zeros. And then the last term is minus 300 into minus 1. It will become plus 300. So plus 300. So now we have 1,300,000. So that's 10 lakh and 300 minus the sum of this. So we will get it as 100,0300 minus 30,001. 30,000,0001. Okay, so we have 100,300. So it is this plus this minus these two numbers. Okay, minus 1 minus 30,000 is minus 30,001. So we just need to subtract this, and we will have our final answer for this particular evaluation. So this evaluates to 970,299. Okay, so that is our answer for 99 power 3. So 99 cube is 970,299, and we have obtained this answer by using the x minus y the whole cube identity. Okay, so this is, as we said, one of the uses of using these identities is also to evaluate certain calculations. Similarly here, just as we have used x minus y the whole cube here, this particular example is going to use x plus y the whole cube. So we want 102 the whole cube. So that's 102 the whole cube. We can write 102 as 100 plus 2 the whole cube. So now this is of the form x plus y the whole cube. So x plus y the whole cube equals x cube plus y cube plus 3xy into x plus y. Okay. So now in place of x we have 100, and in place of y we have 2. So we just need to substitute in place of x and y. So we can write our 102 cube as 100 plus 2 the whole cube, which is 100 cube. The first term is x cube, so 100 cube plus y cube. Y is 2, so plus 2 cube plus 3 into x into y, so 3 into x is 100 and y is 2 into x plus y, so that's 100 plus 2. So we need to just evaluate this. 100 cube, like before, is 1 followed by 6 zeros, that's 10 lakhs. 4, 5, 6 plus 2 cube is plus 8. So 3 into 100 into 2 is 600. So that's plus 600 into 100 plus 2. So now that will be 100. So that's 1 million or 10 lakh plus 8 plus this will be 60,000. Plus 600 into 2 is 1,200. So we just need to add these numbers to get our final answer for 102 cube. So it is 10 lakh plus 8 plus 60,000 plus 1,200. So that will give us 1061208. Okay, so that is the evaluation for 102 cube, which we have evaluated using the identity x plus y the whole cube. Okay, so we have seen how we can use the identities to expand the expression, and now we have also seen how to use the identity to evaluate certain calculations. Let us now move on to see how we can use these identities for the cubic expressions to factorize some cubic algebraic expressions. So let's move into that part. So we have an algebraic expression with a degree of 3. That's a cubic algebraic expression, and we will use the identities that we have seen to factorize this expression. So clearly, when we look at this particular expression, it looks of this form: x cubed plus y cubed plus 3x squared y plus 3xy squared, so which is 3xy into x plus y. So I just opened up the bracket here. So we get x cubed term. So there is a cube term with x, there is a cube term with y, there is an x squared y term, so x squared y term, and an xy squared term, so an xy squared term. So we just need to figure out what is in place of x and y, and then we will be able to represent that in this form of the identity as x plus y the whole cube, and then we should be able to get the factors of this particular algebraic expression. So let's first write down our given expression, which is 8x cubed plus 27y cubed plus 36x squared y plus 54xy squared. Now we want to write this first term as a cube of a single term. So clearly 8x cubed can be written as 2x the whole cube. So 2x the whole cube will become 2 cube is 8 and x cube is x cube. So we'll get 8x cubed. And similarly, we can write 27y cubed as 3y the whole cube. So now 3y, 3 cube is 27 and y cube is y cube. Okay, so we can write this 27y cube as 3y the whole cube. So we got the x cube term and the y cube term. Next we have 3 times x squared y, so plus 3 times, so x squared, so in place of x, okay, in place of x, okay, we have 2x here, right? So the term x here, which is x cube, we have 2x the whole cube. So in place of x we have to put 2x, so 3x squared will become 3 into 2x the whole square, so 3 into 2x the whole square. And in place of y we have 3y, so we'll write the 3y as it is. So that's 3y plus 3xy square, so we have the 3 as it is. In place of x we had 2x, so that's 2x, and in place of y we have 3y, so that will be 3y the whole square. So now we have our expression of the form x plus y the whole cube, where in place of x we have 2x and in place of y we have 3y. So in place of x, when I have 2x, I get 2x the whole cube, so 2x the whole cube. And then we have in place of y 3y, so 3y the whole cube. And then we have 3x squared y, so 3x is 2x squared y is 3y, plus 3x is 2x and y is 3y the whole square. Okay, so basically we have from the identity the variable x is mapping onto 2x and the variable y is mapping onto 3y. So this expression is basically 2x plus 3y the whole cube. So this basically evaluates to 2x plus 3y. So in place of x we have 2x and in place of y we have 3y. So this resembles the identity for x plus y the whole cube, in wherein in place of x we have 2x and in place of y we have 3y. So it's 2x plus 3y the whole cube. So now 2x plus 3y the whole cube can be split out as 2x plus 3y. Anything power 3 means the same thing multiplied 3 times. So 2x plus 3y into 2x plus 3y into 2x plus 3y. So that's those are the factors of our given algebraic expression. So 2x plus 3y, 2x plus 3y, and 2x plus 3y. And these are the 3 factors. So eventually we have this algebraic expression evaluating to 2x plus 3y the whole cube, because it resembles the identity for x plus y the whole cube. So again, the whole idea, the whole trick here is to identify the pattern in the given expression and relate with which particular identity it matches, and then figure out what is in place of x and y. Okay, x and y are general variables, but the given expression may have some other parameters in place of x and y. Like in this particular case, in place of the variable x we have the parameter 2x, and in place of y we have 3y. So you need to figure out what is the parameter in place of the variables in the general expressions for the identities. Okay, and that way you will be able to solve the problems. Okay, so this is going to take a little bit of practice for you to have a clearer understanding and to make these calculations without any errors. So I recommend that you practice these problems quite a lot so that it will be very clear. Okay, generally it is very simple, but you do need some practice in order to be clear about the process. So let us now do one more example of factorization from the exercise, from question number 8 of exercise 2.4. So we are given an expression 8a cubed plus b cubed plus 12a squared b plus 6ab squared. So again, instead of the variable being x and y, we are given the expression in terms of a and b. But clearly the expression matches our general form of the cubic expansion for x plus y. So it's x plus y the whole cube. We get it as x cubed plus y cubed plus 3x squared y. So in place of x squared y, we have a squared b, and xy squared, we have ab squared. Okay, so we need to represent or express this expression in the form of in the same form as in the identity, and then we will figure out what is in place of x and what is in place of y, and then we will be able to represent it in this form to get the factors. So let us first write down our given expression, which is 8a cube plus b cube plus 12a square b plus 6ab squared. Okay, so how can we write 8a cube as some form of x cube? So clearly again it is 2a power 3. So 2a power 3 will give us 8a cube, and b cube is simply going to be b cube, so b remains b. And then in our identity we have 3 times x squared y. So in place of x we have 2a, so that's going to be 3 times 2a square. So in place of x we have 2a, so it's 2a square, and y is simply b, so into b, plus the last term is 3 times xy square. 3 times x is 2a, and y is b, so that's b squared. Okay, so now this is of the form of this identity, where in place of x we have 2a, so the 2a corresponds to x and the b corresponds to y. So we have now in the form of x plus y the whole cube. So this is x cube, which is 2a cube, y cube, which is b cube, 3x squared y, which is 3 into x is 2a, so x squared is 2a squared, y is b, plus 3 into xy squared, so x is 2a and y is b, so it's b squared. Okay, so that corresponds to x plus y the whole cube. So in place of x we have 2a, so that will be 2a, and in place of y we have b, so it's 2a plus b the whole cube, so which we can write as 2a plus b into 2a plus b into 2a plus b. Okay, so we have factorized this expression again using the x plus y the whole cube identity, which is identity number 6 that we have seen in this chapter. Next, let us do one problem which uses the identity for x minus y the whole cube. Okay, so we have seen how to use the x plus y the whole cube identity for factorizing the algebraic expression. Let us now look at another example, which is also a problem from the exercise. Question number 8, division 4. You are given this expression, 64a cubed minus 27b cubed minus 144a squared b plus 108ab squared. Okay, again clearly it is of the form x minus y the whole cube, because when we expand x minus y the whole cube we get this expression, and when we open up this bracket we get the terms x squared y and xy squared. So in place of x and y we have the given expression in terms of a and b. So we'll just try to rewrite the given expression in the form of the right hand side of the identity, and once you have written it, then we'll be able to figure out what is in place of x and y, and then we can substitute to the left hand side to get it as the cubic, and that way we will be able to find the factors of this particular expression. So again what we are doing here is factorizing. So let me write it, I forgot to write there. So it's factorize. Let's write down our given expression: 64a cube minus 27b cube minus 144 a square b plus 108 ab squared. Okay, so now let's try to write the first term as sum x the whole power 3. So clearly the cube root of 64 is 4, so we can write it as 4a the whole cube. So 4a the whole cube, 4 into 4 into 4 is 64, and a into a is a cube. So 4a the whole cube is 64a cube, and minus, in place of y we can write 3b the whole cube. So 3 cube is 27, so 27b cube. So we have a x cube minus y cube. So in place of y we have 3b, and we have to now substitute x and y. So in place of x clearly we have 4a, and in place of y we have 3b. So we just need to substitute that in the remaining part of the expression. So it is minus 3 times x square. X is 4a, so x square is 4a square, and y is 3b. So now when we expand this, let's see whether we get the same 144 minus 144 a square b. So 4a the whole square will be 16a square, and 16 into 3 is 48, and 48 into 3 is 144. Okay, clearly we get the same answer. So it's 3 into 4a the whole square into 3b, and the last term is 3 times xy square. So plus 3 times, in place of x we have 4a, and in place of y we have 3b the whole square. So now let's evaluate this and see if we get the same 108ab square. So 3 square is 9, 9 into 4 is 36, and 36 into 3 is 108, okay, into a into b square. Okay, so it matches, everything is evaluating correctly. So we now have our expression as x cube minus y cube minus 3x square y plus 3x y square. So in place of x we have 4a, so the 4a corresponds to x, the 3b corresponds to y. So again here the 4a corresponds to x, the 3b corresponds to y. So we have x cube minus y cube minus 3x square y and plus 3xy square. So the 4a is again x and the 3b is y. So basically that corresponds to x minus y the whole cube. And what is x in this case? X is 4a and y is 3b. So we have 4a minus 3b the whole cube, and 4a minus 3b the whole cube is 4a minus 3b multiplying 3 times. So it's 4a minus 3b into 4a minus 3b into 4a minus 3b. Okay, so these are the factors of the given algebraic expression. So we were asked to factorize it, and we saw that this particular expression matches the identity for x minus y the whole cube, and we rewrote this expression in a form that resembles the right hand side of this identity. And once we were able to do that, we were able to figure out what is in place of x and y. So in place of x we saw that we can see clearly that it is 4a, and in place of y we can see clearly that it is 3b. So now we have x minus y the whole cube, which is 4a minus 3b the whole cube. So this is our final answer for the factorization. So far we have seen up to, we have done examples using the identities up to identity number 7. Okay, so there's just one more identity left, which is identity number 8. And the next problem that we are going to do is going to use the identity number 8. Okay, so the example problem is to factorize this expression 8x cubed plus y cubed plus 27z cubed minus 18xyz. And if you look at this particular expression, it is having the form of the identity number 8, which is x cubed plus y cubed plus z cubed minus 3 into xyz, which is given by this expression on the right hand side. So we need to rewrite the given expression in terms of the identity form and figure out what is in place of x, y, and z, and that way we will be able to rewrite this in terms of the right hand side to get the factors. So let us do that. So we'll start with our given expression, which is 8x cubed plus y cubed plus y cubed plus 27z cubed minus 18xyz. Okay, so we need to rewrite this expression in terms of the in a form that resembles the general expression for the identity. So we want it as x power 3. So we can write this 8x cubed as 2x power 3. So in place of x, we are going to have 2x. So 2x power 3 is 8x cubed. Y cubed will remain y cubed. And we want it as z cubed. So in place of z, if I take it as a single term, it will be 3z the whole cube, because 3 cubed is 27. 3 into 3 is 9. 9 into 3 is 27. And z power 3 is z cubed, right? So the 27z power 3 can be written as 3z the whole cube. So now we can see that in place of x, we have 2x. In place of y in the general expression, we have y in the given expression. And in place of z in the general expression for the identity, we have 3z. And we can write it further into 3 times xyz. So since we have in place of x, we have 2x, so we will write it as 3 times 2x. In place of y, we have the same y, so we will write the y as it is. And in place of z, we have 3z. So where we have z cubed, it is 3z the whole cube. So in place of z, we have 3z. So now let's see, when we multiply this term, we get the same minus 18xyz. So we have 3 into 2, 6 into 3, 18. 6 into 3 is 18. So minus 18 into x into y into z. So it's minus 18xyz. Okay. So now this corresponds to the form of the general expression for the identity number 8. So in place of x, we have 2x. So let's write that. X maps to 2x. Y maps to itself as it is. And in place of z, it is mapping to 3z. So now we are just going to substitute in place of x 2x, in place of y y, and in place of z 3z to the right hand side of this expression, and that will give us the factors of this particular expression. So on the right hand side, we have x plus y plus z. So we will write it as in place of x, it is 2x. In place of y, it is y. And in place of z, it is 3z. Okay, so it is 2. In place of x, I have written 2x here because x is corresponding to 2x as we see from this expression here. Y is y, so we'll leave it as it is, so y. And plus z, and in place of z, we have 3z here. So it is 3z. And that is, and then we have the next part in the brackets. So it is x square. So x is 2x, so it is 2x square plus y square. So y is y, so it's y square plus z square. In place of z, we have 3z square minus x into y. So minus, in place of x we have 2x and y is y, minus y into z. So in place of y is y and z is 3z, minus x into z. In place of x we have 2x and in place of z we have 3z, and you just need to simplify that. So that gives us 2x plus y plus 3z into 2x square is going to be 2x the whole square is 4x square plus y square plus 3z the whole square is 9z square minus 2xy minus 3yz minus 2 into 3 is 6 times xz. Okay, so we just squared these terms. So 2x the whole square is 4x square and 3z the whole square is 9z square, and the rest of the terms we just simplify. Minus 2xy minus 3yz minus 2 into 3 is 6xz. Okay, so that is our final expansion. So the factors of this particular polynomial or this particular expression are given by this particular term, which is 2x plus y plus 3z multiplied with 4x square plus y square plus 9z square minus 2xy minus 3yz minus 6xz. So so far we have seen examples of using all the 8 different identities that we introduced at the beginning of this particular topic. So all the 8 identities have been shown how to be used for factorization or for simplification or evaluation of some expression or quantity. Okay, so we will stop here for this particular session. There is some more examples that we will be doing using these identities, which I will be covering in the next class. So to summarize now, in this particular session we have seen 4 different identities, in fact 3 identities related to 2 variables with a degree of 3. Okay, x plus y the whole cube, x minus y the whole cube, and then we saw the final identity number 8, which had the form of x cube plus y cube plus z cube minus 3xyz, which is given by this expression on the right hand side. Okay, so we have seen all these examples in all these identities and how to use these identities to solve different types of expressions. Okay, so we will continue with some more examples, and one more identity which is not listed, but we will create that identity in the next session, and we will see how that particular identity can also be used to simplify certain algebraic expressions and also to evaluate certain computations.